We've mentioned earlier that the abstract factory pattern is used to create families of classes. Each member of this family will have some features which are in common with other members. It's only that the implementation details are different for every member of this family. However, this wasn't very clear, so I think it makes much more sense to see what families of classes mean with an example and see how the abstract factory pattern can really help us here. In order to understand this more clearly, we'll go back to the original example where we spoke about databases. Say that your company wants to switch from databases provided by Microsoft to one provided by Oracle. A new CEO has joined. So the CEO wants to make everyone move to an Oracle based database. Now, previously we spoke about one database being used by everyone, but that's typically not how it works. In any company, you'll have an entire production system which uses many different databases. So basically, you might have a system where you use only read-only databases. You might have a system which uses advanced features and requires a more powerful database. So it's not a single database that you use, it's multiple databases with differing features. You want to move this entire suite from Microsoft to Oracle. So based on the kind of support that a production system needs, it could choose a particular flavor of database. That flavor could be read-only, a light version of the database, a professional version of the database, and so on and so forth. Each flavor can be considered a family of products. And every company will probably supply one database in that family. So every database system, every database provider such as Microsoft or Oracle would have different implementations for each of these flavors. So let's say we assume a read-only database. Microsoft will have its own efficient read-only database, as will Oracle. So you assume a professional edition of a database. Microsoft will have its own version. Oracle will have its own version. Each company contributes one member to the family, where the family is the database flavors. So you can have light versions, professional editions, or read-only versions. Maybe within your company, the light version might offer limited functionality, less storage, and maybe used for internal systems, which don't really need to handle a very heavy load. It's a perfectly legit use case. You don't want to pay the license fees for a very heavy database system. You might, on the other hand, have professional editions which would run on user-facing systems. These are fully fledged offerings and will have the most powerful features. You'd use that for your front-end system which your users see. And you might have read-only versions which will be used for bulk read operations and are optimized to be really fast for read. They don't really perform editing or updating functions really well. Now, each flavor can be considered to be a family of databases. The read-only flavor is a family of its own. Microsoft might have its read-only database, Oracle might have its read-only database, as might any other database provider. For example, the professional edition. Microsoft might have its own, Oracle might have its own, and so on and so forth. Every company contributes one member to a family. Maybe multiple members, but at least one member to a family of databases. This is where the abstract factory pattern comes in. It's precisely to manage these families that we'll use the abstract factory pattern. Here, we want to basically say, I want a read-only database or I want a professional database and not have to worry about whether Microsoft has provided it or Oracle. Basically, I want to use the configuration file which we saw earlier in earlier lectures pertaining to the factory method, which basically say whether it's Microsoft or Oracle. Take a look at the code on screen. This is typically how you'd set up the abstract class database factory. This allows you to get at different families of databases, whether it's light, professional, or read-only databases. So the database factory, the abstract class, has a get database light, it has a get database pro, and it has a get read-only database. Every implementation which derives from the abstract database factory will have implementations which return its own version of that family member. So the Microsoft implementations will return its own light database, own professional database, and own read-only database, as will the Oracle implementation of this database factory. Note that the interface for a read-only database is probably a little different. It'll probably be iRead-only database. It'll no longer be iDatabase as we saw earlier. It probably has just limited functionality, no write commands, only read commands. Now, going back to the transition which the CIO of the company wanted to make, both Microsoft products and Oracle products should provide every member of these families for the transition to be successful. So the Oracle version needs to provide a light database, a professional database, and a read-only database for the transition to be successful. Let's see how the class setup of the database factory and its derived classes will be. This is something you've seen before, but kind of refreshes your memory and allows you to see what a family of databases look like. So we have the abstract database factory at the root of this hierarchy, which basically allows you to access different families of databases. The Microsoft factory, which provides implementations and adds one member to each family, as well as the Oracle factory, which provides its own implementations and adds one member to each family, derive from the abstract database factory. So both Microsoft and Oracle will provide light versions, professional versions, and read-only versions of their database. They add to every family that we want. This should continue to work as before, as we saw in the factory method and the abstract factory discussions that we had in earlier lecture. When we switch from Microsoft to Oracle products, we simply change the real factory that we used. We use either the Microsoft factory or the Oracle factory based on what's specified in the config file. We'll still have access to all families of products. And provided everything has been set up correctly, all our database flavors should work as it did before. So the pre-switchover and the post-switchover states should ideally not be affected. Thus, the abstract factory pattern is useful to create families of products while abstracting away the creation and implementation details from the user.